As you know that we were discussing about the autocorrelation problem, how to detect the autocorrelation problem, what are the consequences of autocorrelation problem in the regression model, and how to take remedial measure when the regression model suffered from the problem of autocorrelation. And we have also seen some application using this data. And today I told you that today we are going to solve a problem which is actually coming from your text. Would you please move on to page number 451, page 451, problem number 14.15. Page 451, problem number 14.15, that is from the third edition of your text. পেয়েছেন সবাই?
Yes, sir.
So here you are actually given a regression model which has been estimated with the dependent variable, which is showing the personal consumption expenditure, and independent variables are x2 followed by personal disposable income, and second independent variable is x3, which is D. Jones Industrial Average Stock Index or Capital Market Index, very simply. So the regression is based on the US data from 1961 to 1985. That means 5 years data. So according to the estimated values or estimated result, which is applicable for this regression model, you have been asked to calculate or asked to show that is there any first order autocorrelation problem in the residuals of this regression? How do you know? So the first thing that they asked you to justify that whether the regression model they have estimated, does it have any autocorrelation problems or not? So we know that we can observe the autocorrelation problem by calculating the value of D statistic or Durbin-Watson D statistic. So this D statistic is given here as 0.8755. But this calculated D statistic does not tell us directly whether the regression model suffers from autocorrelation problem or not. What we have to do is we have to compare this calculated D statistic with the critical value of the D statistic, which is actually coming from the tabulated values with a lower limit D value and upper limit D value, depending on the two parameters. One is how many independent variables you have used in your regression model, and what is the sample size, right? So in that case, we can see that in this problem, in this regression estimated result of the regression model, we can see that the value of D statistic is given 0.8755. So if you just go back to the end of your text to know the tabulated values of the D statistic, upper limit and lower limit value of the D statistic at 5% level of significance, when at page 528 in your text. So the critical values for the 25 years is the sample size. So 25, from the first column take 25, and corresponding to 25 you have to take k equals to 2. That means you have two independent variables here in this model. So we can see that the intersecting values of lower limit value is 1.206 and upper limit D value is given 1.550. So DL is 1.206 and DU upper limit value is given 1.550, right?
Yes, sir.
Okay. Then I told you to prepare a graph comparing your calculated flow and tabulated D values that you have derived from the D statistic table corresponding to a level of 5% level of significance. So here the D value starts from 0 and maximum D value can be 4. And I told you that the first column belongs to the region, which is the rejection region of the null hypothesis. There are two null hypotheses you have to assume. One is no presence of positive autocorrelation. And null hypothesis star is no presence of negative autocorrelation. Okay. So from 0 to lower limit of the DL, D statistic value, sorry, and the upper limit of the D statistic value. So this is the upper limit of the D statistic value. So here the values are given 1.206 and upper limit values 1.550. And from this upper limit value to this region, which is actually 4 minus DU, and this one is 4 minus DL. Okay. This is the system to this is the procedure to develop the graph, which is showing the comparative position between your calculated D statistic and tabulated D statistic. Okay. And here 4 minus D is 4 minus 1.550. So what is the value you have here?
Sir, 2.45.
2.45. And 4 minus DL, that means 4 minus 206.
Sir, 2.794.
2.794. So I told you that these are the region which are actually the region known as indecision point, zone of indecision. These are the point of zone of indecision. You are not certain whether model suffers from autocorrelation problem or not. And here from 0 to DL, if your calculated D statistic value is fallen below the lower limit of the DL, so this is the zone where you are actually rejecting null hypothesis, and that is the zone. That means your calculated D statistic is fallen between 4 minus DL and 4, then you are rejecting another null hypothesis, which is followed by null hypothesis star. And this is the region, which is the green region actually. You are accepting both hypotheses, null hypothesis and null hypothesis star. Okay. Now your calculated D value is 0.8755. So it is fallen under which area?
Rejection area,
Rejection
evidence
area.
of positive correlation.
Okay, so it is fallen under that. The calculated D value is fallen below the lower limit of the D value. So when it is lower limit of the D value, it is fallen under lower limit of the D value, then we are rejecting the null hypothesis. And our first null hypothesis was no presence of positive autocorrelation. But when we are rejecting this null hypothesis, we are actually assuming that there is a presence of positive autocorrelation. Right? So that is the answer of requirement number A. That according to the critical D values corresponding to 5% level of significance, we reject H0 and conclude that model suffers from positive autocorrelation. Model suffers from positive autocorrelation. Okay. Is that clear to everyone?
Yes, sir.
Yes, sir.
In the second requirement, you are given there in the question, using the Durbin two-step procedure. Two-step procedure means I told you there is a remedial measure you can take by calculating or estimating the rho value. Rho is the correlation or coefficient of correlation or coefficient of autocorrelation actually, which lies between -1 to +1. So using that Durbin-Watson two-step procedure, the preceding regression was transformed as per equation 14.15. Transformed per equation 14.15, yielding the following result. That means I already discussed the method of transformation using the or incorporating the value of the rho. That means you have to transform the original regression model, which is your equation number 1, by taking their one period lag values, both in the dependent variable as well as in the independent variable, and multiply rho value with that one period lag value and take the first difference. Take the first difference means deduction between equation number 1 and equation number 3. Maybe this one I already discussed in the last class. If you can recall, remedial measure, okay? Transformation of the regression model. মনে আছে? Last class এটা দেখিয়েছিলাম।
Yes, sir.
Yes, sir.
So a transformation টা তারা use করে, using this transformation, they have re-estimated the regression model where it shows that R square is 0.9816 and D value is 2.28. Okay, and other T ratio and slope coefficients are also given. Then number C, okay, before number C, has the problem of autocorrelation been resolved? How do you know? They have asked you in number B that has the problem of autocorrelation has been resolved. How do you know? So it actually basically depends on your calculated in number B when they have transformed the regression model. This is number B. The calculated D statistic is showing what is the value of D now? 2.28, right?
Yes, sir.
2.28. 2.28. Now, if you compare it, okay, one thing that I actually missed in the last class, and at the end, after finishing the class, I realized that I missed one issue, which is when you actually transform the regression model, you can see that this transformation method that you have followed in the remedial measure step to remove the problem of autocorrelation, you actually use the 1 year lag period. Okay. In this transformation, you can see that this one, T minus 1, when you are taking equation number 2, T minus 1, that means you are taking actually 1 year lag period data. That means if you have the earlier year is 2019, prior to 2020, earlier year is 2019, that means you are actually ignoring 2020's data. That means out of your total data set, if there are 20 observations, then you are actually ignoring one observation because you are restructuring the regression model depending on 1 year lag period data. So if your total regression model's variable data set consists of 20 observations, you are actually ignoring one observation from there, right? In that case, what would be your total amount of observation in this transformed regression model?
19.
19 যদি 20 থাকে সেখান থেকে আপনি 1 মাইনাস করছেন মানে 1 ইয়ার ল্যাগ পিরিয়ড থেকে শুরু করছেন দ্যাট মিন্স একটা ইয়ার কারেন্ট ইয়ারটা আপনি মাইনাস দিচ্ছেন না কারেন্ট ইয়ারের অবজারভেশন ইউ হ্যাভ নট ইনক্লুডেড দ্যাট সো দ্যাটস ওয়াই this current year observation would be deducted or ignored from the total number of observation. The total number of observation in earlier stage, if it were 20, now it has become 19. In that case, when you are transformed the regression model and recalculated the D statistic, you have to compare the tabulated value of the D statistic corresponding to n or sample size equivalent to 19, not 20. আমার কথাটা বুঝতে পারছেন?
Yes, sir.
আমরা বোধহয় গত ক্লাসে আমি এটা বলতে ভুলে গিয়েছিলাম, আমি জাস্ট আগের যে ডি স্ট্যাটিস্টিক ছিল, মানে আগের যে টেবিলটা ছিল, সেই tabulated ভ্যালুর সাথে বোধহয় আমি কম্পেয়ার করেছি।
Ji, sir.
The earlier tabulated value was based on the 20 observation, but when you actually transform the regression model, one period has been already lagged and your total number of observation has been deducted by one period and it has become 19. So your critical d values will be changed in that case. Critical d value টা তখন আবার চেঞ্জ হবে, 19 অবজারভেশনের জন্য আবার আরেকটা critical value দেওয়া আছে। Similarly here also our initially in the original model our lower limit of d value was 1.206, upper limit of d value was 1.550. Then we have actually transformed the regression model using the one period lag data series. Then our total number of observation has been reduced by one data or one observation. So initially our total number of observation was 20. এখানে যখন আমরা DL আর DU calculate critical value of D নিয়েছিলাম from the table, their n value was 25, right? Now here n value has become 24 because of that transformation. বুঝতে পারছেন?
Yes, sir.
Yes,
Okay,
sir.
now from the table, just go back to your T table again at 5% level of significance. Now your total number of observation has become 24. So corresponding to 24, for the two variables, okay, two independent variables, your lower limit of D value is 1.88 and upper limit of D value is 1.546. দেখতে পাচ্ছেন সব? Can you all see?
Yes, sir.
Lower limit of D value is 1.1 1.188 and upper limit is 1.546. Though there is no significant difference between the DL and DU of observation 25, but still sometimes it matters. So the lower limit of D value is 1.188 and upper limit of D value is 1.546. Okay.
Yes,
Now
sir.
just re-estimate the graph again. Now your lower limit value is 1.188, 1.546. And if you just deduct this upper limit value from 4, it will be 1.244, right? এরকমই বোধহয় থাকে নাকি? খুব বেশি তো ডিফার করে না, দেখেন কত আসে। 4 minus 1.546 কত?
2.454.
454. আর 4 minus DL, that means 4 minus 1.188.
2.812.
812.
2.
Okay. Now your calculated D value is 2.28. Now you tell me what is your decision, rejection point or acceptance point or
Acceptance
zone of
ratio.
indecision. So you can see that
Acceptance.
2.28 is fallen between 1.546 and 2.454, right? Here is 2.28. So it is fallen under the acceptance zone. So acceptance zone means you have accepted both null hypothesis, which is no presence of positive autocorrelation as well as no presence of negative autocorrelation. So in number B, after making the comparison between the calculated D statistic and critical D values, we can conclude that ওই কথাগুলো লিখে নিয়েন যে making the comparison, we can conclude that the transformed model does not suffer from autocorrelation problem. Okay, is
Yes,
it clear
sir.
to everyone? Okay.
Yes, sir.
Yes, sir.
Now number C, comparing the original and transformed regression. The t-value of personal disposable income has dramatically dropped. What does this suggest? Number C তে বলেছে ওরা যে t statistic misspelled হয়েছে, sorry. T statistic of PDI in original model, it was 70 point something, right? 70.2936. And T statistic of personal disposable income in transformed model is 30.72. 30.72. So what do you think? Why this T statistic has been drastically dropped when you transform the regression model? What is your suggestion? Can you recall the
Sir.
consequences of autocorrelation in the regression model? I told you that when the regression model suffers from autocorrelation problem, then it will inflate the t value. বলেছিলাম?
Yes, sir.
As per the consequence, it will inflate the t values, and when the t value has been inflated, then there is a possibility that you are rejecting a null hypothesis which was supposed to be accepted. Did I clarify this in the earlier class?
Yes, sir. Yes,
Yes,
sir.
sir.
So that is what you have to write down here, that in number C, it suggests that the autocorrelation problem is suffering the regression model, or regression model suffers from autocorrelation problem, then it will inflate the t value or t statistic of a OLS estimator or OLS estimators. Okay, and that is why, or so that the t statistic of personal disposable income in the original model, we know that original model suffers from autocorrelation problem, right?
Yes, sir.
Original
sir.
model to autocorrelation problem chilo. So you have to write down this, that as we know, the problem of autocorrelation causes inflated t statistic for OLS. The t statistic of PDI was inflated due to which correlation we have identified or detected in
Positive autocorrelation.
positive. In the earlier model, it was suffering from the positive autocorrelation. So that is what you have to write down. The t statistic of PDI was inflated due to positive autocorrelation in earlier model. When the transform model removes this problem, autocorrelation problem has been removed, the t statistic of PDI has been dropped. Okay, যখন autocorrelation problemটা remove হয়ে গেল in the transform model, then as a consequence of removing autocorrelation problem from the model, the T statistic of personal disposable income has been dropped. That is what we can suggest. Is that clear to everyone?
Yes, sir.
Yes, sir.
Number D. Is the D value from the transform regression of any value in determining the presence or lack thereof or autocorrelation in the transform data? So what do you think? D value যেটা ক্যালকুলেট করেছেন বা যেটা পেয়েছেন from the transform regression model, এটা কি ইন্ডিকেট করে? কোনো autocorrelation presence আছে নাকি আপনি lack of thereof মানে হচ্ছে you cannot make any decision, that means it does not tell you any decision, or it is actually fallen in the zone of indecision of autocorrelation in the transform data. কি মনে হয় আপনার? এটা অলরেডি নাম্বার বি তে তারা
Yes,
জিজ্ঞেস
sir.
করেছে, আবার ইনডিরেক্টলি ডি তে আবার অ্যাকচুয়ালি জিজ্ঞেস করেছে আপনাকে, তো অলরেডি আনসার দিয়েছেন
Autocorrelation.
নাম্বার বি তে, তো ওই একই আনসারই এখানে দিবেন যে the d value which is calculated from the transform regression model has been used to determine that there is no presence of autocorrelation. Okay, is that clear to everyone?
Yes, sir.
The d value that you have calculated or found from the transform regression model has been used to determine that the model does not have any autocorrelation problem, or there is no presence of autocorrelation problem in the model. Okay,
Yes, sir.
so after this move on to the next page, and you have to solve one problem by yourself, which is 14.19. That is already known to you. They have given you a model 14.19 in page number 453. Can you all see page
Yes, sir.
453?
Yes, sir.
This is just a given model consisting of 3 independent variables. And here they have given you this model and also mentioned some assumption that suppose the error term follows the AR1, that means Markov first order or first order autoregressive model. Autoregressive means the error term follows the earlier years or 1 year lag period error term. How do you transform this model so that there is no autocorrelation in the transform model? So they have also given you the hints that extend the equation 14.15. That means the transformation we have learned in the earlier class. The same transformation would have been applied in this original regression model. First, you have to take their 1 year lag period data. Then you have to multiply that 1 year lag period data with the value of rho, and rho value can be calculated by 2 ways that I have already shown you in the last class. And after this transformation, just take the first difference between equation number 1, that means your original regression model, and your newly formed regression model, which was found after multiplying the rho value with the 1 year lag data of the dependent and independent variable. এটা বুঝতে পেরেছেন কি করতে হবে?
Yes, sir.
Yes, sir.
মানে আমি এটা অলরেডি গত ক্লাসে আপনাদেরকে যে ট্রান্সফরমেশনটা দেখিয়েছি ওইটাই আর কি। আমি দেখিয়েছিলাম কয়টা ভেরিয়েবল ছিল? It consists of only 2 independent variables, right? Here they have given you how many independent variables?
3.
3. So it's same approach time and same remedial measure যেটা আমি নিয়েছিলাম for the transformation to remove the autocorrelation problem. Same remedial measures have been followed here, would have been mentioned here to remove the problem of autocorrelation. But in this case, your original regression model consists of 3 explanatory variable, right?
Yes, sir.
Yes, sir.
Okay, so এটা পারবেন আশা করি নাকি?
Yes, sir.
Yes, sir.
So that is the end of your autocorrelation chapter also, and that is the end of discussion from this text. And if I just go back to your course outline, I told you that in your course outline there were almost 10 or 11 chapters that we have covered from this text, and another 2 or 3 chapters maybe that will be covered from the reference text, and that would be actually completely based on the software. Okay, so from today we are going to start the application of the software, application of the regression model using the data. So let me open my course outline first. আচ্ছা, আরেকটা ডিক্লারেশন দিয়ে দিই এর মধ্যে। From now again there will be one class per 1 week, okay, and that would be only on Tuesday. রোজার মধ্যে আসলে 2 ঘন্টা করে 2 দিন নেওয়াটা একটু ডিফিকাল্ট হয় আমার জন্য। তো আমরা যেটা করব, যেহেতু আমাদের সিলেবাস অলমোস্ট শেষ, উই আর অ্যাকচুয়ালি ডান উইথ অটো কোরিলেশন পর্যন্ত শেষ আমাদের, দেখতে পাচ্ছেন কোর্স আউটলাইনটা।
Yes, sir.
ওকে, সো সেই ক্ষেত্রে আমি আর বাকি আছে অ্যাকচুয়ালি 3 চ্যাপ্টারস আর রিমেইনিং: panel data econometrics, time series econometrics, and limited dependent variable econometrics. These 3 chapters actually based on the advanced econometrics. আমি যেটা হচ্ছে শিখাবো এই জন্য আপনাদেরকে, because there would be a master's thesis at the end of your second semester of the master's MBA program. You will have to conduct a thesis. So what I actually think that if you are done with these 3 chapters, if you have already if you could have done with these 3 chapters, you can apply those readings or those models in your master's thesis, okay, and that will actually enrich your master's thesis. You can after completing the master's thesis, even if you have completed your master's thesis, whatever the grade you will have, that doesn't matter. The matter is you can publish your master's thesis in a journal form, okay, in a paper form. তো সেই কারণে আপনাদেরকে এই 3টা চ্যাপ্টার আমি শেখাবো, যাতে করে এগুলার অ্যাপ্লিকেশন গুলো থিসিসে করতে পারেন, প্রত্যেকেই যাতে করতে পারেন, এবং করতে পারলে আপনাদের থিসিসটা অনেক বেশি এনরিচ হবে। এখানে একটা গাইডলাইন দেওয়া আছে, গাইডলাইন্স অফ প্রিন্সটন ইউনিভার্সিটি ইউএসএ। দিস গাইডলাইন ইজ অ্যাকচুয়ালি রিলেটেড টু চ্যাপ্টার 12, that is chapter 19 here, panel data econometrics. Guidelines of the Princeton universities, they have actually published this guideline, how to conduct the panel data econometrics. So I will follow this guideline whenever we are actually discussing any topic from this chapter. And there is a reference text. I have given you reference text number 2. If you wish, you can read the reference text number 2 for these 3 consecutive chapters. Basic econometrics, which is also written by the same author, Gujarati, 5th edition, still available in the online. You can take the soft copy. এটার সফট কপি আছে, আপনি চাইলে অনলাইন থেকে ডাউনলোড করে নিতে পারবেন, ওকে। And so let's start this chapter, panel data econometrics. There are a number of models that we have to know, how those model, in which circumstance we'll have to use, and in one circumstance we can see that none of this panel data econometrics model will be consistent or will be effective in estimating the OLS estimators. In that case, we'll have to go for an alternative measure, which is followed by GMM approach, or generalized methods of moment approach, okay. That is actually the last topic of this chapter, panel data econometrics, one step system GMM, okay. So first of all, the initial discussion starts with what is panel data. You know that panel data is a combination of both time series data and cross-sectional data, right? এটা তো জানেন।
Yes, sir.
Okay, so when you are given a panel data set, how do you analyze them in a regression model, or how do you analyze the regression model for a panel data set or panel data observations? There are actually 4 approaches we can use. One is pooled OLS method. The first one is pooled OLS method. Second one is fixed effect method. Third one is random effect method. And fourth one is cross-sectional FGLS, cross-sectional fixed generalized least square method. FGLS মানে হচ্ছে, FGLS stands for fixed generalized least square method, okay. I will show you one by one. So first of all, let me open my data set. So this is the data set which was created by one of the students from 21st batch, and he was doing the internship or master's thesis under the supervision of me. So that is the data he has collected, and I will show you the panel data econometrics on this data set. Okay. So first I am collecting the data set from the Excel sheet. So there are 7 commercial banks he has selected, and those 7 commercial banks, 10 years data, started from 2010 to 2019. And actually, the title of his thesis report was Nexus or Relationship between share price and the financial performance of the commercial banks. So a panel evidence from the Bangladesh, that was the title. So actually here the dependent variable was price earning ratio, that was indicating the share price movement or stock market performance of the respective commercial bank. And there are 7 independent variable or explanatory variables he has taken in the model. Those 7 variables are actually based on the financial performance of the respective commercial banks. So first one is LQ, indicates the liquidity ratio. Second one is LV, stands for leverage ratio. NPM, net profit margin ratio. NIM ratio, NIM, net interest margin ratio. AUR, asset utilization ratio. LA stands for loan to asset ratio, and NPL means non-performing loan ratio. Okay. So let me copy this data to the Stata. So ED stands for edit. You will get the data editor, then paste the data in the data editor from the Excel sheet. Treat first row as variable name, so automatically data editor takes the first row as variable name. Then actually you have to, as this is a panel data, you have to make Stata understand that this is actually a panel data, for which you have to write some command. The first one is encode company name, which is actually the entity name or company name or group name or cross-section name. Generate banks. So you have generated another variable. If you just look at that, so here ABBL, this is the first bank, BA Bank Asia, then BRAC Bank, then Deep Dutch Bangla Bank, Eastern Bank, IFIC Bank, and Mutual Trust Bank. Okay, so these are the 7 banks which has been already taken as under the variable name banks. Okay. We did not give the company name here because company name was the original data set. We have encoded this company name into another variable name, which is banks, and that is our panel variable. Okay, that means that is our cross-sectional or group variable against which the time series variable have been given. Now we are going to write another command which makes Stata understand that which one is time or which one is time variable and which one is panel variable. We have to write down xt set, x for panel, t for time, or x for cross section, t for time. Xt set, then our bank is the cross section or group, and here is the t for time, and press enter. Then panel variable is banks, they have all automatically taken. Time variable is year, which is started from 2010 to 2019. After that, first of all, I told you that when you are going to conduct any regression analysis for a panel data set, there are 4 approaches you can follow. The first one is the simple approach that we have already discussed in all our earlier chapters, which is OLS method, square method. In the panel data set, it is actually known as pooled OLS because we are actually pooling, or we are coordinating both the time series data as well as cross-sectional data. So that's why this panel data set for which we are constructing the regression model, this regression model will be estimated. That means this regression model's coefficient or OLS estimators will be estimated considering the method which is known as pooled OLS. Okay. So it is very simple. Just write REG. Then your dependent variable is price earning ratio. Then your all independent variables would be selected here. And after that, press enter. So this would be the output generated by the stata for your panel data set of regression model. And the regression model which you have estimated here using the stata, the method is known as pooled OLS. Okay, pooled OLS method estimates the coefficient value of each of the independent variable along with the constant. So the explanation I'm not giving to you because you know how to explain the value of the coefficients of each of the independent variable. You know how to explain the R square value, how to explain the adjusted R square value, how to explain the F ratio or F statistic. And also you also know that how to explain the SSR. That means here sum of a square due to the estimated regression model, that means SSE that was earlier. Now it has been SSM. M means from the model. Okay, sum of a square due to the explanatory variables included in the model, and sum of a squares due to the residual. Okay, and this is the total sum of a square. It is already explained in the earlier chapter. I'm not going to explain them. I think you can do this by yourself, right?
Yes, sir.
Okay.
Yes, sir.
So that is the one approach we can estimate OLS estimators of the regression model using the pooled OLS method. From this, you can estimate the variance inflation factor value or VIF value to show the problem of the multicollinearity in your regression model. You can see that none of them have been crossed the value of 5 in VIF. So none of the independent variable is causing any multicollinearity problem, and the mean VIF value is 1.53, which is far lower than the 5, right? So the model does not suffer from any multicollinearity problem. Okay.
স্যার
জি।
এখানে রিগ্রেশন মডেলে পি ভ্যালুতে একটা শুধু 0.05 এর নিচে বা 0.05 এর সমান, তো সেই ক্ষেত্রে এতগুলো ইন্ডিপেন্ডেন্ট ভেরিয়েবলের মধ্যে যখন একটা ভ্যালু শুধু সিগনিফিকেন্ট হয়,
শুধু
এই এটা কি কোনো প্রবলেম ক্রিয়েট করে? যে
প্রবলেম, অনেক প্রবলেম আছে, দেখাবো আমরা। একটা প্রথমে দেখলাম যে কোনো মাল্টিকোলিনিয়ারিটি প্রবলেম নাই। এর পরের প্রবলেমগুলোতে গেলেই দেখবেন এখানে অনেক প্রবলেম শুরু হবে। এখানে অটোকোরেলেশন প্রবলেম পাবেন, এখানে হেটারোস্ক্যাটাস্টিক প্রবলেম পাবেন। যে কারণে আপনি নান অফ দি ইন্ডিপেন্ডেন্ট ভেরিয়েবল, মানে অলমোস্ট নান অফ দি বলতে পারি, একটা শুধু পেয়েছি আমরা সিগনিফিকেন্ট। অলমোস্ট নান অফ দ্য ইন্ডিপেন্ডেন্ট ভেরিয়েবলস আর ফাউন্ড সিগনিফিকেন্ট। তো সেই ক্ষেত্রে আমরা ওয়্যারলেস না হলে যাব ফিক্সড ইফেক্টে, ফিক্সড ইফেক্ট না হলে যাব র্যান্ডম ইফেক্টে, সেটা দিয়ে না হলে যাব যে জিএলএস, মানে 4টা মেথড বলেছি না, 4টা মেথডে আমরা দেখবো টেস্ট করে। কোনো মেথডে যদি পাওয়া না যায় তার মানে সেখানে আরেকটা প্রবলেম আছে যেটাকে আমরা বলি ইন্ডোজেনিটি, আমি বলবো এটাও। সো ইন্ডোজেনিটি প্রবলেম থাকলে তখন আমরা জিএমএম বা জেনারেলাইজড মেথডস অফ মুভমেন্ট অ্যাপ্রোচ দিয়ে করি, তখন সেখানে হয়তো বা বেশ কিছু ভেরিয়েবল আপনি সিগনিফিকেন্ট পাবেন। ওকে, তো
জি স্যার।
এখন থেকে যেহেতু দেখলাম যে ভিআইএফ দিয়ে টেস্ট করে দেখলাম দেয়ার ইজ নো প্রবলেম অফ দ্য টেস্ট ফর other one, that is specification টেস্টে যান, সেখানে হেটারোস্ক্যাটাস্টিক প্রবলেম আছে কিনা সেটা দেখেন। দেখেন কি অবস্থা, কি মনে হচ্ছে? আছে প্রবলেম?
Yes, sir.
Yes, sir.
So BPLM test for heteroscedasticity. Heteroscedasticity আমরা এখানে যেটা আছে মানে by default we have a heteroscedasticity test which is followed by the BP test incorporated in our stata package, but you can also do it using the PARC test or White's heteroscedasticity test by measuring the estimating the residual from the regression model. ওটা করেও আপনি করতে পারেন, বাট দরকার নাই। আমরা যেটা প্যাকেজে আছে what we have in our statistical package, we can just do it by writing only one command or by clicking a few from the menu bar. So সেটা যেটা আমরা খুব সহজে 1 সেকেন্ড 2 সেকেন্ডে করতে পারছি, এটার জন্য এত কিছু কমান্ড লেখা তো দরকার নেই, বুঝতে পারছেন? এখানে residual park test করতে গেলে you know that for the park test you have to know the squared residual, right? So first you have to estimate the residual, then make it square, and then you have to run another regression model against the squared residual with those explanatory variables incorporated in your regression model. Naki. After that, you can decide whether your regression model suffered from heteroscedasticity problem or not. এবং সেটা করতে হবে. In case of the park test, you can do it individually for every independent variable, or you can do it by taking the estimated values of the regression model. এখানে already তারা fitted values of the p, মানে estimated values of the dependent variable দিয়েই করেছে। সো যেটা অলরেডি প্যাকেজে আছে সেটা ইউজ করাটাই আপনার জন্য ভালো, তাড়াতাড়ি হবে কাজটা। কারণ যখন আপনার অ্যাকচুয়ালি ডিলিং উইথ দ্য হিউজ ডেটা সেট, তখন ওই সব ছোট ছোট ডায়াগনোসিস টেস্ট করার জন্য ইফ ইউ আর রাইটিং মেনি কমান্ডস, দেন দিস উড বি ভেরি মাচ ক্লামজি ফর ইয়োর হোল থিসিস। তাই এত ছোট ছোট কমান্ড দিয়ে দিয়ে আপনি পার্ক টেস্ট বা হোয়াইট হেটারোস্ক্যাটাস্টিসিটি টেস্ট করতে গেলে আপনার এখানে অনেকগুলো লিস্ট অফ কমান্ড হয়ে যাবে। তখন আপনি অনেক সময় যদি ইফ দেয়ার ইজ এনি মিস্টেক অর এরর হ্যাপেন্ড ইন ইউর কমান্ড, ইট উইল বি ভেরি মাচ ডিফিকাল্ট টু ইউ ফর টু আইডেন্টিফাই where you have made the mistake or where you have made the actually mistakes in your list of commands. So সেই জন্য I always suggest you, whatever the statistical package, that means your stata package, what it has incorporated, it has already incorporated all the types of diagnosis test of the regression model. সব ধরনের diagnosis test আপনি করতে পারবেন, যে which we have already learned in our autocorrelation problem or heteroscedasticity problem or model specification test problem or even in the multi-clonality test problem. আমরা জেনে আসছি এগুলো সবই এখানে অটোমেটিক্যালি টেস্ট করা যায় বাই গিভিং এ সিম্পল কমান্ড, সেটাই আমরা দেখছি। ওকে, তো আপনি VIF টাইপ করলে ইউ ক্যান গেট দ্য ভ্যালু অফ দ্য VIF, whether your model suffers from multi-clonality or not, you can easily understand it from here. If you write down ESTAT HET মানে stands for heteroscedasticity test, T is ST for test, and it shows that your null hypothesis is constant variance. If your data set has the constant variance, there is no problem of the heteroscedasticity, right? But
Yes.
if your data set has non-constant error variance, then your data set has the heteroscedasticity problem. Okay, so as per the calculated value of the chi-square, our p-value is 0.0000, which is far less compared to 0.05, right?
Yes,
So
sir.
what is the decision you can take here? Null hypothesis
Null
has been
hypothesis
rejected.
Rejected.
So if your hypothesis constant variance is rejected, it means the data set has non-constant variance, non-constant error variance. So it concludes that your data set is severely suffering from the heteroscedastic error variance problem or heteroscedasticity problem. Is that clear to everyone?
Yes, sir.
Yes, sir.
Then test for autocorrelation is that DW আচ্ছা, এখানে একটা জিনিস খেয়াল করেন, D statistic or Durbin-Watson test would not be applicable for the panel dataset. Second, sample may not include the panel multiple. Okay, D statistic you cannot calculate it for the panel. Calculate it only for the time series data. So now, if you want to know that whether your panel Durbin alt, you can also test with Durbin alt. This will say the same thing. Sample may not include the multiple panels. Can you all see?
Yes, sir.
Okay. Then in that case, how can you actually test that whether your panel data set suffers from autocorrelation problem or not? In that case, there is a new command you have to write down, xt serial. xt serial. xt for panel, that means x for panel, t for time, serial means for autocorrelation, serial autocorrelation test. Then regress dependent variable against the all independent variables. After that, you can see that the output generated by the stata will reach test for autocorrelation in panel data. So in panel data, to test the autocorrelation, Ullrich has suggested a model where the null hypothesis is there is no first order autocorrelation, no positive, no negative autocorrelation. Okay. And he has calculated the F ratio, which is found 21.503, whose p value is 0.0036. Which is what? P value is less than
0.05.
0.05, which concludes what? Null hypothesis has been accepted or rejected?
Rejected.
Rejected. So if null hypothesis is rejected, what is the conclusion you can draw?
There is either positive or negative autocorrelation.
There is the first order autocorrelation, right?
Yes, sir.
Yes, sir.
তার মানে আমরা once we have just diagnosed the result, estimated result from this panel data set using the pooled OLS method. আমরা যে মেথডটা ইউজ করছি, its name is pooled OLS method. From there, we have identified two problems. One is this model suffers from heteroscedasticity problem. Another one is this model also suffers from autocorrelation problem. Okay. Another thing you can also do for model specification test, which is regression error specification test for omitted variable. So here, omitted variable test cannot be appropriate or will not be appropriate for the panel data set. Okay, এটা এখানে আপনি ইউজ করতে পারবেন না। So panel dataতে আপনি শুধুমাত্র you can calculate the VIF for multicollinearity test. You can calculate the heteroscedasticity test for using the BP test, and you can also calculate autocorrelation test, also calculate or detect the autocorrelation problem in your regression model, considering this command, xt serial, dependent variable, and all other independent variables. Okay. Now, our conclusion is this model suffers from two problems. One is heteroscedastic error variance, another one is autocorrelation. Okay. After that, we will estimate this model using the fixed effect model. Fixed effect model in our regression, in our chapter, I told you that panel data econometrics consists of 4 methods. Pooled OLS, this is the pooled OLS method we have just discussed. Then the next one is fixed effect method. Its name is fixed effect because here the intercept, the constant we will estimate from the regression model. This intercept or constant will not vary over time. I repeat, in the fixed effect model, there are two assumptions actually. The first assumption is the constant or intercept we will estimate from the model. This constant or intercept will not vary over time or across the time. That means from one time to another time, or from one point of time to another point of time, the intercept or constant will remain same, or more simply, it is actually time invariant. Time invariant, টাইমের সাথে সাথে এটা ভ্যারি করবে না। আমার কথাটা বুঝতে পারছেন? It will remain fixed or it will remain constant. And another assumption is, this is the first assumption for the fixed effect method. The first assumption is, আমি আবারও বলছি, the first assumption for the fixed effect method is the intercept or constant we will estimate from the regression model, it will not vary over time. It will remain constant or fixed across the time, or more simply, it is actually time invariant. And second assumption is between the, yeah, within the group or within the entity. That means we have taken 7 banks here. There are 7 banks in our data set, right? 7টা entity আছে নাকি?
Yes, sir.
Yes, sir.
So within this entity or within these banks, there are some factors that may affect your independent variables or that may affect your explanatory variables. Okay. For example, the CEO, if the CEO is male or female, because of their decision, because of their gender discriminatory or because of the CEO's gender, it might be possible that the share price of the bank will be affected. Or we can say the managerial efficiency for all of these 7 banks are not same. There might be some differences in the managerial efficiency. Also say that the management structure of these 7 banks are not similar. The management structure or management positions will be different for one bank to another bank. But whatever the management structure they have, this will remain same for a specific period of time. Say for next 3 years or 4 years, one MD or one CEO will operate the company. Or next 3 years or next 4 years, same management structure will be followed for each of the bank. Okay. But inside this every bank, inside this every entity, these are some factors that may be related or that may affect the independent variables because of the management structure, because of the CEO's decision. Maybe the independent variables will be affected from one bank to another bank, right? এটা তো usual হতেই পারে নাকি?
Yes, sir.
Yes, sir.
Yes, sir.
So the fixed effect regression model, the second assumption is inside every entity, there are some factors that will affect the explanatory variables, that will affect the independent variables. That means variation within the entity, more simply, or in the language, formal language, we can say variation within each entity is statistically correlated with the explanatory variable of your regression model. Second assumption টা কি বোঝা গেছে?
Yes, sir.
Variation within the entity can affect the explanatory variable of your regression model. Or more simply, we can say variation within the entity is correlated with the explanatory variable of your regression model. Okay. These are the 2 basic assumptions of the fixed effect method. When actually fixed effect method has been estimated, as I told you that its first one is its constant or intercept will not vary across the time. But the question is, how can you actually estimate the fixed effect method, or what is the command to estimate the wireless estimators using the fixed effect method for your regression model for the panel data set? The command is almost similar to the earlier pooled wireless method. It would be started from XTREG. XT stands for panel data set. Okay. REG for regression, dependent variable, and all other your independent variables. Then put a comma, put a space, and write down FE. FE stands for fixed. That means you are measuring or estimating the wireless estimators from this regression model considering fixed effect method. And for this, of course, panel data set. And then press enter. So you can see the title is fixed effect regression. Group variable is bank. R square within between overall. This is actually SSM or SS regression, R square within the entity, R square between the entity, that means between the banks, and overall R square. Overall R square is very poor. Can you see 0.1295?
Yes, sir.
So it is actually very poorly fitting the data set. And you can see that correlation between the UI and XB. This is the second assumption that I was discussing. That second assumption means inside the entity there are some factors which is not observable, which is actually unobservable, or which is actually known as error term inside the entity or inside the organization. The error term within the entity. Okay, within the entity, these error terms are correlated with the explanatory variable. XB stands for the explanatory variables coefficient. Okay, and here we can see that the correlation between the error term within the entity and the explanatory variable is found minus 0.3554. দেখতে পাচ্ছেন?
Yes, sir.
Yes, sir.
Okay, and if you examine the F statistic, joint significance of the model, it is also found insignificant. P-value is more than 0.05, right?
Yes, sir.
Yes, sir.
And almost all p-values are insignificant. And sigma U and sigma E. Sigma U means standard error of the residual within the entity. I repeat, sigma means standard error. Standard error of whom? Standard error of the residual within the entity. ওই যে ইউটা হচ্ছে residual within the entity or within the bank or within the group. আর সিগমা ই যেটা দেখতে পাচ্ছেন এটা হচ্ছে standard error of the residual of overall model. That means overall মডেলের যে error টার্মটা আছে সেইটার standard error হচ্ছে standard error of the residual of the overall model. সিগমা ই দিয়ে যেটা বলছে। আর RHO রো ভ্যালু, RHO টা দেখতে পাচ্ছেন রো ভ্যালু।
Yes, sir.
Yes, sir.
রো ইজ দ্য intra class correlation বলে এটাকে বলা হয় intra class correlation. It means that the correlation of a given cross section, that means correlation of a specific bank, say there are 7 banks, so the correlation of a specific given cross section means correlation of a given bank between the error terms of 2 point of time. মানে হচ্ছে ধরেন একটা ব্যাংক হচ্ছে ব্র্যাক ব্যাংক, সো ব্র্যাক ব্যাংকের যে এরর টার্মটা আছে, ব্যাংকের এরর টার্ম, if the error terms of the brag bank of 1 point of time, say 2019, is correlated with the error term of brag bank with another point of time, say 2018. 2019 এর error termটা of brag bank is found correlated with the error term of brag bank in 2018. Then this is actually known as row value. Row means intra-class correlation between the error terms of 2 point of time, 2 different points of time. আমার এক্সপ্লেনেশনটা কি বোঝা গেছে? ধরেন
Yes,
ব্র্যাক
sir.
ব্যাংক বলছেন, ব্র্যাক ব্যাংকের মধ্যে যে এরর টার্মটা আছে, দিস এরর টার্মস মে বি ফাউন্ড কোরিলেটেড উইথ 2 পয়েন্ট অফ টাইম। ব্র্যাক ব্যাংকের তো 10 ইয়ার্স ডেটা আছে না?
Yes, sir.
Yes, sir.
Okay, so if 1 year's error term is found correlated with the another year error terms within the brag bank, মানে ওই একই ব্যাংকের একই এন্টিটির মধ্যে যদি আমার 1 year's data set error term is found correlated with another year's data set error term, then it would be estimated by the value rho, RHO rho. ঠিক আছে? And it is found at 0.2677, which means 26.77% variation in the dependent variable, which is actually price earning ratio. 26.77% variation in the dependent variable happens due to the differences across the panels. প্যানেলের মধ্যে যে ডিফারেন্সটা আছে, এই ডিফারেন্সটা থাকার কারণে, মানে প্যানেলের যে এরর টার্মের মধ্যে ডিফারেন্সটা আছে, এই ডিফারেন্সটা থাকার কারণে the deviation or variation in the dependent variable followed by price earning ratio happens, and this ratio is 26.77% variation. 26.77% variation in the dependent variable P ratio happened because of the differences across the panels. Let me show you lens which is issued by the Princeton University for the explanation of the panel data set when you have regressed them against the fixed effect method. এটা কি আপনাদের দিয়েছিলাম এই শীটটা? মনে হয় দেই নাই, আজকে দিয়ে দিব, ঠিক আছে? আচ্ছা, আমি একটু রো এর এক্সপ্লেনেশনটায় যাই। সবাই দেখতে পাচ্ছেন?
Yes, sir.
Yes, sir.
Okay, this is the explanation of the row. They have estimated that 0.2972, that means 29.7% of the variance is due to the differences across panels. Okay, with the differences across the panels happens because within the panel or within the group, the error terms are correlated from one point of time to another point of time. And that is what actually estimated with the row value, and row value has been calculated with sigma u square divided by sigma u square plus sigma e square. Sigma u means, I already told you, a standard deviation of the residual within the group, that means within the panel or within the entity. And sigma e stands for standard deviation of the residual, which is overall error term of the model. Can you all see it from the my screen?
Yes, sir.
Yes, sir.
So, sorry. Okay, now for this fixed effect method, you can see that none of the independent variable is found statistically significant at 5% level of significance. None of them is significant as per the calculation, and it is also proved from the estimated output of the regression model that the p-value of the F statistic is more than 5%, which means jointly all of the explanatory variables are not statistically significant in affecting the dependent variable price earning ratio. Okay. এটা তো ক্লিয়ার সবার কাছে আপ টু দিস ডিসকাশন?
Yes, sir.
স্যার, যখন আমার পুলড ওএলএস কাজ করে না, বা আমাকে অনেকগুলো ইনসিগনিফিকেন্ট ভ্যালু দেখায়,
হ্যাঁ।
তারপরে কি আমি ফিক্সড ইফেক্ট মেথডটা অ্যাপ্লাই করি?
হ্যাঁ, ফিক্সড ইফেক্ট অ্যাপ্লাই করবেন, বাট আমি আরো কয়েকটা মডেল দেখানোর পর আপনাকে বলবো যে ইফ ইউ ফাউন্ড দ্যাট মানে দেয়ার ইজ সাম মডেল স্পেসিফিকেশন টেস্ট হুইচ উইল গাইড ইউ দ্যাট হুইচ মডেল ইজ দ্য বেস্ট ফর ইউ। মডেল স্পেসিফিকেশন কিছু টেস্ট আছে, সেটা দিয়ে আপনি ডিসাইড করতে পারবেন যে আমি যে ওএলএস মডেল পুলড ওএলএস এ যাব নাকি ফিক্সড ইফেক্টে যাব নাকি র্যান্ডমে যাব। ওকে, আগে আমরা জাস্ট শিখে নিই যে কিভাবে one of the model can be estimated. Okay, now after estimating the fixed effect model, you can test its diagnosis. You can also conduct its diagnosis test. VIF already you have calculated, it's not required to be calculated again. In the pooled OLS, you have already calculated VIF. VIF is okay. Multicollinearity, there is no multicollinearity problem, right? In the data set, there is no multicollinearity problem. এটা একবার ক্যালকুলেট করলেই বোঝা যায়, সেটা সবগুলোর জন্য একই রকম। VIF for pooled OLS, VIF for random effect system, everything is same. একবার ক্যালকুলেট করলে আপনি পেয়ে যাবেন যে মাল্টিকুলারিটি প্রবলেম আছে কি নাই, সেটা নাই আমরা দেখে আসছি, তাই তো? নাও we'll test for heteroscedasticity problem in the fixed effect model, right? বুঝতে পারছেন? We
Yes,
are
sir.
not going to test the multicollinearity again under the fixed effect model because we have already tested that none of the independent variables have any multicollinearity problem in the earlier method. এখানে আমরা অলরেডি দেখে আসছি যে মাল্টিকোলিনিয়ারিটি প্রবলেমটা নাই, সো এটা নিয়ে আর আমাদের অত বোদার হওয়ার কোনো কারণ নাই, কনসার্ন হওয়ার কোনো কারণ নাই। So what we have been concerned about the earlier two problem, heteroscedasticity on autocorrelation test. এই প্রবলেমটা গিয়েছে কিনা এটা আমরা টেস্ট করব। So XT test 2. Sorry, not XT test 2, XT test 3 প্রথমে, তারপরে 2 বলবো আমি। XT test
স্যার এখন কোনটা
আচ্ছা,
দিয়ে করা
একটা
হচ্ছে
টি
স্যার?
পড়ে নাই, হ্যাঁ সরি XT test 3. Modified Walsh test for group-wise heteroscedasticity in fixed effect regression model, right? Null hypothesis is sigma I square. Sigma I exponent 2 মানে হচ্ছে sigma I square is equal to sigma I square for all I. মানে for I means group here. That means I means panel here. Panel 1, panel 2, panel 3. That means there are 7 panels or 7 groups in the data set we have. So we are assuming that sigma I square, that means the error variance we have calculated, this would be similar or constant for every panel or every group. That is the null hypothesis. So if it is found that null hypothesis is accepted, then there is no problem of the heteroscedasticity. But as per the calculation of the chi-square tested statistic, the p-value is 0.0000. So again, our conclusion is fixed effect model does not remove from the heteroscedasticity problem in the earlier regression model. Okay, so fixed effect model is also suffering from the same heteroscedastic error variance problem. Error variance is not found constant across the group or across the panel. বুঝতে পারছেন?
Yes, sir.
Okay. Now test for serial autocorrelation XT serial. Same autocorrelation problem has not been resolved yet, right?
Yes, sir.
Yes, sir.
আচ্ছা, তো আরেকটা টেস্ট আমরা একটু আগে আমি দিয়েছিলাম XT টেস্ট 2, এটা হচ্ছে সরি XT টেস্ট 3। আচ্ছা, এটা একটু লাস্ট এস্টিমেটটা আবার করে নিই আমি, দাঁড়ান। QUI quietly. Sometimes you can just estimate the fixed effect regression model or pooled OLS regression model by just simply writing quietly XTREG. Quietly মানে হচ্ছে সে চুপচাপ এস্টিমেট করে বসে থাকবে, আপনাকে এস্টিমেশন রেজাল্টটা দেখাবে না। ওকে, quietly regress price earning ratio against the other independent
স্যার
variable.
কমান্ড একটু ভুল আছে স্যার, এক্স আর ইজি হবে।
দিচ্ছি আমি, দাঁড়ান। আচ্ছা, হ্যাঁ, এটা একটু খেয়াল করেন, আমি আসলে খুব স্ক্রিনে এমনিতে দেখা যাচ্ছে খুব ছোট, তার উপর লিখতে হচ্ছে যে কমান্ড গুলো সেগুলো খুবই ছোট ছোট। LA then NPL. Okay, did I take all the explanatory variables? LQ, LV, NPM, NIM, LA, NPL. Okay. So he has already, Stata has already estimated these fixed effects.
স্যার, what is the objective of estimating this quietly?
Sorry.
What is the objective of estimating it quietly?
Oh, quietly means because you have already estimated it in the earlier stage. এখানে তো estimate করেছেন already, তাই না? So when you have estimated it in the earlier stage, you should not show it again in your display, or again you should not show it again in your display. It is actually estimated in a hidden form, and then we will test whether our cross-sectional dependence happens between the error terms or not. মানে আমি আসলে দেখতে যাচ্ছি যে error term-এর মধ্যে কোনো cross-sectional dependence আছে কিনা। তো অলরেডি তো আমরা আগে এটা এস্টিমেট করেছি, এটা আবার এখানে ডিসপ্লেতে আমার শো করার দরকার নাই। So that is why I have just write down quietly estimate the regression model using the fixed effect method. So it will just estimate it quietly, that is estimate it and make it hidden form. It will not show you in the display. And after that, if you just make any diagnosis test, XT test 2,
Sir.
it will show you the correlation matrix of the residuals. Yes.
স্যার,
স্যার
আচ্ছা,
অ্যাসেট
আমি
ইউটিলাইজেশন
dependent
রেশিওটা
variable
বাদ গেল না?
একটা রেশিও বাদ গেছে?
বাদ দিয়ে দিলাম। জি স্যার, AUR।
আচ্ছা আচ্ছা, দাঁড়ান, সেটাই আমি জিজ্ঞেস করছিলাম যে কোনোটা মিস হয়েছে কিনা। AUR না, আফটার নেম। Okay, so just you have quietly estimated the fixed effect regression model and make it in the hidden form. The output is in the hidden form because your objective is not to show them in the display, but to test some diagnosis, or but to check some diagnosis of the estimated regression model, because already you have estimated the fixed effect in the earlier display here. Your fixed effect regression model has been already estimated. You should not show it again in your display. After that, once you have quietly estimated the regression model using the fixed effect method, it will just estimate it quietly, make it in the hidden form, and then you can proceed for the other diagnosis test, say XT test 2. Okay, so XT test 2 is actually done for the cross-sectional dependence test. That means whether the residual of one panel is correlated with the residual of the another panel. I repeat, XT test 2 is actually estimated or calculated for cross-sectional dependence test. Cross-sectional dependence test means whether the error term or whether the error of one group or one panel is correlated with the error of another panel. আমার কথাটা কি বুঝতে পারছেন? একটা প্যানেল একটা গ্রুপের যে এরর টার্ম আছে,
Yes, sir.
the mean error termটা, whether that mean error of the one panel is correlated with the mean error of the another panel or not. So this is actually done by the correlation matrix of the residual, and this correlation matrix of the residual, by observing the correlation matrix of the residual, a chi-square tested statistic has been calculated where the null hypothesis is, এখানে null hypothesis আবার বলে নাই, এখানে আবার null hypothesis আপনাকে ধরে নিতে হবে with your assumption. Null hypothesis is there is no dependence of the error terms across the panels. Or I can say that if I just share the if I just share the Princeton guidelines, they have already given you the explanation of the diagnosis test of the cross-sectional dependence test. Here it is. Can you all see?
Yes, sir.
Using
Yes, sir.
Brishach-Pagan LM test of independence. So actually this has been suggested by the Baltegi, one of the econometrician. He has said that cross-sectional dependence is a problem in the macro panels with a large time series data, say 20 to 30 years. So if your data set has only 10 years data, you need not to calculate this cross-sectional dependence test, or you need not to go for any cross-sectional dependence test. If your data set consists of at least 20 years data, then you can proceed for this. And this cross-sectional dependence test actually indicates that interdependence is the residuals across the entities. As I already told you, that whether the residuals across the entities are not correlated. Residuals across the entities are not correlated. So your null hypothesis is the residual that you have estimated, the residual that has been estimated from one panel, that residual should not be correlated with the residual estimated from the other panel. একটা প্যানেলের রেসিডুয়াল যাতে আরেকটা প্যানেলের রেসিডুয়ালের সাথে কোনোভাবে ডিপেন্ডেন্ট হতে না পারে বা রিলেটেড হতে না পারে, that is why we are doing this cross-sectional dependence test. Is the objective clear to everyone why we are doing this?
Yes, sir.
Okay. But remember one thing, that cross-sectional dependence test will be applicable for a large volume of time series data, at least 20 years data. So here the null hypothesis is there is no dependence or independence, is that residuals across the entities are not correlated. That means they are not dependent on each other. Panel residuals are not dependent on each other. And after the, in our estimated regression result, what we have actually found, we have found that our chi-square value is 57.740 and p-value is 0.0000. That means there is a high degree of cross-sectional dependence. That means the residual of one panel is highly correlated with the residual of another panel. Is that clear to everyone?
Yes, sir.
Yes, sir.
একটা প্যানেলের রেসিডুয়াল আরেকটা প্যানেলের রেসিডুয়ালের সাথে হাইলি কোরিলেটেড। তার মানে হচ্ছে আমরা একটু আগে দেখে আসছি there is a autocorrelation problem. The combined error term of the regression model is autocorrelated, or there is autocorrelation problem in the combined error term of this regression model. But here, from panel to panel, from one panel to another panel, the error terms are also correlated. So this cross-sectional dependence test has been also adopted, and we have found that there is a high degree dependence among the panel among the error terms of the panels in the data set. So that is what you can do in the fixed effect regression model. And after that, once you have done with the fixed effect regression model with the heteroscedasticity test, autocorrelation test, and multicollinearity test, then you can proceed with the random effect model. Okay, the third methods that has been suggested in the panel regression model. In there, you just write down the command is xtreg. Then your dependent variable PE independent variables are given here. Put comma, then leave space, write E. RE stands for random effect. Okay, and then press enter. You can see that title is random effect GLS regression. GLS stands for generalized least square regression, because here the original regression model has been a little bit transformed. I will show you the transformation, how they did the transformation. The transformation actually has been done in the intercept portion. Okay. Here, when you are doing the random effect regression model, you can see the chi-square value of the model is 16.38 and their p-value is less than 0.50. So in overall significance, when you have gone through the random effect GLS regression model, you can see that overall all explanatory variables are affecting the dependent variable P ratio. Okay. But individually, only one variable is found statistically significant, NPM or net profit margin ratio. So net profit margin ratio is found statistically significant in affecting the price earning ratio. And all other independent variables are still found insignificant in explaining the deviation or variation in the dependent variable price earning ratio. Can you all see it from the output?
Yes, sir.
Yes, sir.
Here, one thing that you need to assume, they have assumed, this is the second opposite assumption that you have assumed in the fixed effect. I told you that second assumption in the fixed effect was inside the entity or within the entity, there are some factors that will cause changes in the explanatory variable, or more simply, we can say that within the entity, the error terms within the entity are correlated with the explanatory variable. But here, the second assumption that you have assumed in the fixed effect model, that is opposite in the random effect model, which is there is no correlation within the entity errors, within the entity's error term and the independent variables X. So EY within entity's error term, EY, it is the within entity's error term, which is uncorrelated with the explanatory variable or independent variable. And that's why their correlation is zero assumed. Is that clear to everyone? For the random effect model, this is the difference between random effect and fixed effect model. One of the difference. এটা কি clear কিনা বলেন?
Yes, sir.
No, sir. Can you please repeat
তার মানে
it?
in the random effect model, they are assuming that there is no correlation within the entity's variation and the explanatory variable or independent variable in your regression model. Okay. Just the opposite assumption of the fixed effect model, second assumption. আচ্ছা, আরেকটা assumption যেটা fixed effect ছিল, প্রথমেই বলেছিলাম যে the constant or intercept will not vary over time. বলেছিলাম না in the fixed effect?
Yes, sir.
Yes, sir.
But in the random effect, we will not consider intercept as a fixed constant. Rather, we will consider it as a variable, which will vary over time. Let me transform your original regression model, which you have done in the fixed effect. Okay, just write down me. Let me write down one equation. Uh, okay, say your original model is B1I, then sum of xit, that means there will be a number of independent variables along with their coefficients. Okay, coefficients are written as sum of xit plus error term. Okay, this is your original model in case of the fixed effect, where you are assuming that your your intercept form, which is followed by beta 1 I. Beta 1 I means beta 1, this is the intercept, or this is the will not vary over the time. If it will vary over the time, then I should have written down here IT. That means from one time to another time, there would be a separate constant you will have. But here in the fixed effect model, I did not put down here T, I just put down here I. I means this is constant, or this intercept, this constant intercept will not vary over time, or will not vary across the time. In the random effect model, this beta 1I would be written down as beta 1 plus EI. Okay. EI is the error term within the entity, error term for every entity, and beta 1 is the intercept which would be replaced in the random effect model like this: beta 1 plus UIT. Okay. So there is also time because you have the panel data actually. So here what you can see is this beta 1I, which was actually constant across the time in the fixed effect model, or which was not varying or differentiating across the time in the fixed effect model. In the random effect model, we are considering it as a variable. That means it will vary over time. But you know that your estimated regression output will calculate only one constant. একটাই তো constant estimate করেছে। আপনি দেখেন random effect যখন estimate করেছেন, এখানে আমাদের যে estimated result আছে, here only constant is given. এটা তো অনেকগুলা constant দেয় নাই সে। Did the output leave you with a number of constant for these seven different groups or 7 different panels? It will just
sir.
give you only one constant, right?
Yes, sir.
And this is actually the mean
Yes,
constant.
sir.
This is known as mean value of constant. Mean value of the constant means this is the mean value of the constant which is coming from the 7 group. Group 1, 2, 3, 4, 5, 6, 7. That means group 1 has one constant, group 2 has another constant, group 3 has another constant. Similarly, up to group 7 has another constant. So 7 group has 7 different constant, which was varying over the time over the entity. But when in your random effect regression model, you have estimated the output, you have found that there is only one constant given. But why I am saying that this constant is a variable, vary. Okay, that is why the name of the method is random. Okay, because you have taken their mean values. for all of these 7 groups, there are 7 different constants were estimated, but those 7 different constants have been calculated as a mean value, which will constitute only one constant value in your output of the regression model. And you can see that I have given another error term with this, which is epsilon of IT. This error term is actually the error term which is the deviation, between the mean value of the constant and the individual constant value calculated for each group. আমার কথাটা কি বুঝতে পারছেন? This epsilon IT means another error term. আমি কিন্তু এখানে দুইটা error term দেখছি। এটাকে আমরা বলছি random effect. This random consists of 2 error terms. One error term, this one, is for the whole model. এটা হচ্ছে for whole model, this is the error term. But this error term is the difference between mean value of constant and respective constant value within group. Okay, so for group 1, group 2, group 3, 4, 5, 6, 7. So for these 7 groups, you have 7 different constant value. And these 7 different constants value, when you have take the difference between the mean value of them, অর্থাৎ group 1 এর হয়তো বা constant value আসছে 15, আর এখানে আমার beta 1 value, which is the mean value of the constant, it is found 17. So the difference between 15 and 72, which is the error term, was followed by the notation epsilon of IT. Is that clear to everyone? Why there are 2 error terms here in this random effect model?
Yes, sir.
Error term হচ্ছে for the whole model. এটা হচ্ছে পুরো মডেলের জন্য UIT is the whole model's error term. Another error term is epsilon of IT, which is the error term showing the difference between the mean value of the constant estimated for the regression model and the mean values which the model calculates for each of the group. Okay. So এইটাকে আমরা যখন এইভাবে ডিফারেন্সিয়েট করি, এইভাবে যখন আমরা আলাদাভাবে ডিফারেন্সিয়েট করি here in the model, so this mean value of the constant would be followed by the beta 1. There is no I, there is no T, because we have taken the mean value, which is actually one single value, a constant value. And after that, we have incorporated 2 error terms here. One error term is for the whole model and for the differences between the intercept or constant values of them between the mean values and their group wise values. এই দুইটার ডিফারেন্সকে আমরা এই error term দিয়ে ইন্ডিকেট করি, and that's why sometimes random effect model is also known as ECM or error components model. Error components model. Error components model, okay, because there are 2 error terms. One error term is for the entity, another error term is for the overall regression model. Okay, now when you have estimated your regression model here, you can see the output is very poor here also, because here the overall R square is almost fixed effect model. Fixed effect কত আসছিল R square টা দেখেন এখানে, the fixed effect R square was found on a difference আছে 0.1295, which is showing that poorly fitting of the regression model using the data set. And here in the random effect model, we can see that overall R square value is 0.2090, which means here the data set has been very poorly fitted in the regression model. Okay. Up to this, is it clear to everyone?
Yes, sir.
Yes, sir.
আচ্ছা, এখন আসেন আমি র্যান্ডম ইফেক্ট দিয়ে করলাম, ফিক্সড ইফেক্ট দিয়ে করলাম, ওএলএস দিয়ে করলাম, কোনোটাতেই দেখতে পাচ্ছি যে none of this model actually indicates that most of the independent variables are statistically significant in explaining the variation of the dependent variable. results are actually showing, because the results are showing that because this model actually suffered from heteroscedasticity problem as well as autocorrelation problem. Autocorrelation problem in the overall model, autocorrelation problem in the autocorrelation problem is also found in the panel segment or group segment, because in the earlier cross-sectional dependence test, we have found that the error terms of one model, one panel is also found correlated with the error terms of the another panel. Okay, so because of this problem, none of the models, so none of the method is actually producing a satisfactory result between the relationship of the independent variables and dependent variables. Now the problem is, out of these three model, which model is fitting your regression output very better, or which model is showing the better output of your regression model? I told you in the earlier case that one of you may have asked you that which model, how can we understand? There are some model specification tests which will guide you that which model is better for you. So first of all, when you have estimated two methods, a regression model has been estimated with two methods, fixed effect and random effect. Say again, I am writing down quietly xtreg pe dependent variable and all other independent variables. Leave a put down comma, leave a space, and then just write down fe. So it will just quietly estimate the regression model using the fixed effect method. It will not show you any output here. Similarly, again, quietly regress the same model using the random effect, that means RE. Then it will just put that. Another command you have to write down, estimates store FE. Acha. What I have written here is the estimates that you have found after running the regression model using the fixed effect method. That means the estimated output you have found after running the regression model using the fixed effect method. It has just quietly estimated it and keep it in the random access memory, or we can say keep it in the hidden form. You are just storing that estimated result. And when you are going to store any estimated result that you have found from the OLS method or fixed effect method or random effect method, just write down estimates store FE. You are storing the estimated result of the fixed effect method of your regression model in your data, in your memory. And here you can see that another variable has been created in the data level or variable level. Estimated result has been actually stored here. So you have stored them. Similarly, when you have estimated the regression model using the random effect method, RE, you have just quietly estimated them, but you have not stored the output yet. You are storing the estimated output of your regression model, which was calculated using the random effect method. So estimates store RE. You can see there is another column or variable has been created, ESTRE. That means estimated result of the random effect model has been already stored, already saved. Now you are doing a model specification test between these two estimated, which model is performing better. And this test has been done by Hausman test, right? HAUSMAN, Hausman. FERE. This is actually known as the output of the Hausman test, which will guide you or which will actually suggest you that which method is better between the fixed effect and random effect model for this panel data set. আমাকে একটু আগে একজন জিজ্ঞেস করেছিলেন না যে আমি কিভাবে বুঝবো যে ওএলএস বেটার না ফিক্সড ইফেক্ট বেটার না র্যান্ডম ইফেক্ট বেটার নাকি জিএলএস এখন করি নাই আমরা জিএলএস বেটার, মানে আপনি 4-5টা মেথড দিয়ে এস্টিমেট করলেন which model is better for you. How do you understand this? It would be understood when you are creation result using the fixed effect method and random effect method. First, you have to store the result of the fixed effect method, which is followed by command estimates store FE. Second, you have to estimate your regression model using the random effect method, and then store the estimated result of the random effect method by writing the command estimates store RE. And after that, just write down the command Hausman space FE space RE. That means Hausman test is a test that will suggest you between the fixed effect model and random effect model, which model is better for you. Okay, up to this discussion, is it clear to everyone?
Yes, sir.
Yes, sir.
Okay, now what is the output we have after running the Hausman test? Just look at the chi-square value, the p-value of the chi-square 16.38, and the p-value of the chi-square test is 0.0219, which is actually what? Less than
0.05.
0.05 or 5%. It means what? Your null hypothesis has been rejected. What was your null hypothesis in the test of Hausman? Difference in the coefficients not systematic. More simply, এই কথা হয়তো বুঝতে একটু অসুবিধা হবে। Difference in the coefficients not systematic. এর মানে হচ্ছে when you are doing the Hausman test, null hypothesis assumes that random effect model is better than fixed effect. I repeat, when you are doing Hausman test, its null hypothesis assumes that effect is better, random effect is better than fixed effect. Okay, that is what actually suggested by there also. সেই নিউট্রন টেস্টে পরে আসতেছি আমরা। এই যে just a minute. Okay, fixed or random, considering the Hausman test. To decide between fixed or random effects, you can run a Hausman test where the null hypothesis is that preferred model is random. দেখতে পাচ্ছেন? Preferred model is দেখতে পাচ্ছেন সবাই?
Yes, sir.
Yes, sir.
Preferred model is random effect versus alternative hypothesis is fixed effect. That means more simply we can say when we are running the Hausman test, the null hypothesis is random effect is better than fixed effect, and alternative hypothesis is random effect is not better than fixed effect, or more simply we can say fixed effect is better than random effect. Okay, that's so according to that, when we actually estimated the Hausman test for this panel data set using the fixed effect model and random effect model, we have seen that our null hypothesis has been what? Rejected. So null hypothesis rejected means what? Random effect is better than fixed effect. This assumption has been rejected. What conclusion you can draw in that case?
Fixed effect is better than random
Fixed effect is better than random effect. আচ্ছা, যদি এখানে এরকম পেতেন, মানে এখানে এইটা কম্পেয়ার করলে আমরা বুঝলাম যে ফিক্সড ইফেক্ট ইজ বেটার দ্যান র্যান্ডম ইফেক্ট, এটা আমরা কনক্লুশনে আসলাম, ফাইন। ইফ ইট ওয়ার a different result, say p value is more than 0.5, p ভ্যালুটা যদি 0.05 এর থেকে বেশি আসতো তাহলে কি হতো?
তখন random
effect is better than fixed effect, fine. In that case, when you are going to compare that when you are going to make a conclusion that random effect is better than fixed effect, you have another estimated result which was found using the pooled OLS method. Can you recall pooled OLS method?
Yes, sir.
যেটা প্রথমে আমরা করেছিলাম, একদম সিম্পল ওএলএস দিয়ে যেটা করেছিলাম সেটাকে আমরা পুলড ওএলএস বলি। So when you have done this using the pooled OLS method, there is another test which will be done to compare between the result of random effect method and pooled OLS method. Random effect এবং pooled OLS এর মধ্যে কম্পেয়ার করার জন্য আরেকটা টেস্ট আছে, সেই টেস্টটাকে আমরা বলি এক্সটি টেস্ট 0 দিয়ে করি আমরা। আচ্ছা, ওইটা হচ্ছে that test actually introduced by the BPLM test, which is the same author who has contributed to check the cross-sectional dependence test. Okay, cross-sectional dependence test যিনি introduce করেছে উনি একই ব্যক্তি বা একই same author has also contributed to the diagnosis test between the model specification of two models. One is random effect, another one is pooled OLS method. Which model is better? So there you have to go through with the same thing, which is first of all you have to estimate the regression model quietly, QUIETLY, quietly regress price earning ratio against the all explanatory variables. Okay, so quietly regress price earning ratio against all explanatory variable. This is which method? Fixed effect, random effect, or pooled OLS?
So
Pooled
pooled
OLS.
OLS.
Pooled OLS, right? So it has already estimated and keep it in the hidden form. Now we'll have to store it. Estimates, store, sorry, estimates বানানটা স্পেলিংটা মিসস্পেলড হয়েছে। Pooled OLS. একটা জিনিস খেয়াল রাখবেন, when you are writing command to give any name of the variable should not leave any space in the stata তে variable name এ কোনো space থাকা যাবে না। You can give underscore sign, okay? So estimates store pooled OLS, এটা pooled OLS হিসেবে এখন store হয়ে গেল। দেখেন you have created another variable here in the variable list, okay? Okay, fine. Now again you have to estimate the regression model using the random effect RE. Okay, quietly XT, PE, and all other independent variables, comma, leave a space, and then RE. So this model has been estimated with which method? Random effect method, right?
Yes, sir.
Okay, then put space, and now just write down XT test 0, XT test 0, and leave, put an enter sign, and then you can see Brishach and
Sir,
Pagan
it is
LM
store করা-
multiplier test for random effects. Okay, কিছু জিজ্ঞেস করলেন?
স্যার ওটা স্টোর করে রাখতে হবে না যে র্যান্ডম
না, ওটা স্টোর করতে হবে না, র্যান্ডম ইফেক্ট অলরেডি স্টোর করা আছে। ওই যে দেখেন একটু আগে আমি স্টোর করে রাখছিলাম না, আরই
জি স্যার।
ওই যে হাউসম্যান টেস্ট করার সময় আমি স্টোর করে রাখছি। মানে দুইবার একটা জিনিস স্টোর করা দরকার নেই, বাট পুলড ওএলএস আই ডিড নট স্টোর ইট। এটা স্টোর করার আরেকটা কারণ আছে, তিনটাই যখন আপনি স্টোর করবেন তিনটার আউটপুটকে আপনি একসাথে দেখাতে পারবেন। ওই কমান্ডটা আমি দিয়ে দিব, আজকেই দেখতে পাবেন, এখনই দিব আমি এটা। So you can see that as the output of this output of this LM test model, LM test, which is actually done for testing between the two models, pooled OLS method and random effect method, that which method is better here. Here, when you are doing this test, the null hypothesis is they have test actually variance of u equal to 0. So within using this explanation, it is not possible for you to understand actually which model is better here assumed in the null hypothesis and which model is better here assumed in the alternative hypothesis. So here in the null hypothesis, we assume that random effect is not better pooled OLS. Random effect is not better compared to pooled OLS. And in alternative hypothesis, we are assuming that random effect is better compared to the pooled OLS. Okay, let me show you the guideline which is suggested by the Princeton University for this test. Okay, here. Testing for random effects. দেখতে পাচ্ছেন? BPLM test,
Yes, sir.
testing for random effects. The LM test helps you decide between a random effect regression and a simple OLS regression. The null hypothesis is in the LM test is the variance across the entities is 0. That means across the panel or across the group, there is no variation. The variance of you. That means more simply, the error term in the entity or error term of each of the entity is 0. Or entity's error term is assumed to be 0. Eta hocche null hypothesis. This is this actually means that no significant differences across the units, no panel effect. মানে আপনার এখানে group থাকুক বা group না থাকুক, there is no impact of the group because within the panel the error term is 0. তার মানে there is no impact of different 7 panels, so there is no impact of the different 7 groups. এই 7টা আলাদা group করার কোনো impact এখানে নাই। তো সেই ক্ষেত্রে when we are doing this xt test by leaving the command xt test 0, then it is producing this result here where they have the same p-value which is more than 5%. We have the same p-value which is more than 5%, right? আমাদেরও তো same p-value আসছে, more
Yes,
than
sir.
5%. So what is the conclusion they have done here? They have failed to reject the null hypothesis and which conclude that random effect is not appropriate. তার মানে হচ্ছে null hypothesis আমরা ধরছি এখানে random effect is not better than OLS, or আমরা সহজ করে যদি বলি, if we say just more very simply that null hypothesis assumes pooled OLS is better than random effect. Alternative hypothesis is assuming random effect is better than pooled OLS, right?
Yes, sir.
Okay. So that is the conclusion we can draw here from this LM test for random effect test. And here the p-value is more than 5%, so null hypothesis is accepted, or we have been failed to reject the null hypothesis. So we can see, we can conclude that compared to random effect, pooled OLS is better here between these two models. Our random effect has been already failed to be random effect has been already failed in making the comparison between fixed effect and random effect. তার মানে এখন এখানে একটা conclusion আমরা draw করতে পারি, সেটা হচ্ছে এরকম যে this model can be estimated using either with the pooled OLS method or with the fixed effect method. Random effect would not be appropriate for this model. Is that clear to everyone?
Yes, sir.
Random effectটা এখানে খুব একটা appropriate হচ্ছে না। এই যে আপনি এই data set এর জন্য for this panel data set random effect would not be applicable, or would not be random effect would not be appropriate here, because comparing fixed effect and random effect, fixed effect was better. Comparing random effect and OLS was better. এবং এটার একটা মেজর কারণ কি জানেন? আপনি জাস্ট ডেটা সেটটা একটু দেখেন, write down xt line PE. xt line PE. আমি একটা লাইন গ্রাফ করতেছি which is showing the price earning ratio for all those 7 banks. যেটা করলে বুঝতে পারবেন যে কেন এরকম রেজাল্ট আসছে। এটা এখনো আসলে মানে ড্র করছে। You can see that the graphs are generated for 7 banks. দেখতে পাচ্ছেন?
Yes, sir.
Can you all see the 7 graphs? Okay. These 7 graphs are generated for 10 years period for the dependent variable price earning ratio. Only the ABBL bank's price earning ratio was differentiated between the year 2016 to 2017. All other bank ratio are almost same. There is no panel effect. There is no changes between the groups in the price earning ratio of those 7 banks. দেখতে পাচ্ছেন?
Yes, sir.
দেখেন
Yes,
সবগুলো
sir.
প্যারালালি গেছে, পি রেশিও সবগুলোর অলমোস্ট সিমিলার ছিল। সেই কারণে আপনার এই এত কিছু করে রেজাল্টটা যে পেলেন সেটার কারণ হচ্ছে এরকম যে this regression model can be better fitted using the fixed effect model or the pooled OLS model, but it cannot be fitted using the random effect model, because random effect assumes that the constant will remain random. Constant would be a variable. Okay, a variable, and the second assumption it has assumed that the entities error term are uncorrelated with the independent variables x0. সো র্যান্ডম ইফেক্ট মডেলের সাথে এই অ্যাজাম্পশনটা, এই র্যান্ডম ইফেক্ট মডেলের যে দুইটা অ্যাজাম্পশন ছিল, দ্যাট টু অ্যাজাম্পশনস আর নট কনসিস্টেন্ট উইথ দ্য এস্টিমেটেড রেজাল্ট অফ দি রিগ্রেশন মডেল। সো দ্যাট ইজ ওয়াই when you are tested their diagnosis between the comparing their model specification between these two tests, between this LM test and another one is Hofmann test, you have found that random effect has been failed to justify its efficiency in both in comparing with the fixed effect method as well as comparing with the Wallace method. Okay. Now, the final comment that I am going to give you for today is how can you combine all those coefficients which you have estimated under the pooled Wallace method, fixed effect method and random effect method. আপনি যে pooled Wallace, fixed effect এবং random effect estimate করেছেন এই সবগুলার তিনটা মডেল দিয়ে, সবগুলাকে আপনি একটা টেবিলে কিভাবে আনবেন? আমার কথা বুঝতে পারছেন?
Yes, sir.
So just a minute. Hello. জি জি আচ্ছা, আপনি কি আমাকে কাইন্ডলি হাফ অ্যান আওয়ার পরে ফোন দিবেন? জি জি, আগামীকাল। ঠিক আছে, হ্যাঁ ঠিক আছে, ঠিক আছে। শেষ। Okay, so now just only one command that will combine all the results that you've estimated under the three models. Okay, fixed effect, random effect, and pooled OLS. It is just write down estimates table, pooled OLS, FERE, star, stats, N, chi-square, sigma, F ratio, wherever applicable, sigma U, sigma E. Anything else in the output আর কি থাকে? Chi-square value is already written. F value is already written to sigma is a rho value. Okay. RHO rho. And closure of the first bracket. Okay. I have written down the comma estimates table, pooled OLS, fixed, leave a space, fixed effect, leave a space, random effect, then comma, leave a space, then star, comma, sorry, star, then leave a space, then stats. Then start the first bracket, N, number of observation, chi-square value, wherever applicable, F value, F statistic value, wherever applicable, sigma underscore U, that means the error term, standard error of the residual within the entity, and then sigma underscore E, that is the overall standard error of the model, standard the residual of the whole model, and then the rho value, okay, which is intra-class coefficient of correlation, and then put down enter. Then you can see that your dependent for the variable, independent variable, these are your independent variable, these are the constant. Under the pooled OLS method, these are the coefficients of the independent variable. These are the coefficients are estimated under the fixed effect method. These are the coefficients estimated under the random effect method. Total number of observation N 70, chi-square value applicable for the pooled OLS, applicable for the only random effect method given 16.38, F value applicable for only pooled OLS and fixed effect method given, and then sigma U, sigma E, and rho value applicable wherever under which model. And there is legend given P means the probability value or P value less than 0.05 হলে যদি কোনো coefficients value, if any coefficients P value is found less than 0.05, then there will be 1 star given. if any coefficients p value is less than 0.01, 2 star, and if there is any coefficients p value is found less than 0.01001, that means less than 0.1%, then there will be a 3 star given on the exponent of this coefficient. এখান থেকে দেখতে পাচ্ছি এই যে স্টার গুলা দিয়ে অ্যাকচুয়ালি সিগনিফিকেন্স বোঝানো হয় যে এটা কি স্ট্যাটিস্টিক্যালি সিগনিফিকেন্স না ইনসিগনিফিকেন্ট। তো when you have observed the result that npm is the npm's coefficient under the pooled OLS value is given minus 196.70036. So there is only 1 star given. It is statistically significant at 5% level. And this same coefficient value is also found significant under the random effect model, but under the fixed effect, none of the coefficient is found statistically significant. Okay. So actually this command will put down all the estimated result you have calculated under the each of the model in only one table. এক টেবিলে সবগুলো রেজাল্টকে আপনি কম্বাইন করে নিয়ে আসেন। এটা কি বুঝছেন?
Yes, sir.
Yes, sir.
Okay. So this is up to the discussion on today. There are some other discussion. I will follow it in the next class. Okay. Up to this, is it clear to everyone?
Yes, sir.
Yes, sir.
এইখানে এরকম করে দেখবেন বিভিন্ন জার্নাল পেপার গুলোতে এইভাবে কিন্তু রেজাল্ট গুলোকে নিয়ে আসে। এইভাবে রেজাল্ট গুলোকে আনার জন্য আপনাকে এই কমান্ডটা ইউজ করতে হয়। ওরা কখনোই রেজাল্ট এইভাবে দেখায় না। যে কোনো জার্নাল পেপার নিবেন সেখানে দেখবেন কখনো রেজাল্টকে এইভাবে ফিক্সড ইফেক্ট রিগ্রেশন করে এই টেবিল কখনো দেয় না। এইভাবে কখনো টেবিল দেওয়াটা দিস ইজ নট দ্য প্রফেশনাল। প্রফেশনাল হচ্ছে জাস্ট পুট ডাউন দ্য ভ্যালু অফ কোএফিসিয়েন্ট অ্যালং উইথ দেয়ার ইন্ডিপেন্ডেন্ট ভেরিয়েবলস। ইন্ডিপেন্ডেন্ট ভেরিয়েবলের কোএফিসিয়েন্ট ভ্যালুগুলোকে এইভাবে টেবিল আকারে দেখাতে হয়। যেগুলো স্ট্যাটিস্টিক্যালি সিগনিফিকেন্ট সেগুলো পি ভ্যালু দেওয়া দরকার নেই, জাস্ট পুট ডাউন দ্য স্টার অন দ্যাম। স্টার দিলেই সেটা বোঝা যায় যে হুইচ ওয়ান ইজ সিগনিফিকেন্ট স্ট্যাটিস্টিক্যালি, হুইচ ওয়ান ইজ নট সিগনিফিকেন্ট স্ট্যাটিস্টিক্যালি। আর একটা স্টার মানে হচ্ছে ইট ইজ সিগনিফিকেন্ট এট 5% লেভেল, ডাবল স্টার মিনস ইট ইজ সিগনিফিকেন্ট এট 1% লেভেল, আর ট্রিপল স্টার মিনস ইট ইজ সিগনিফিকেন্ট এট 0.1% লেভেল। ওকে, আপনি চাইলে সিগনিফিকেন্ট লেভেলটা চেঞ্জ করতে পারেন। এখান থেকে একটা আছে কমান্ড, আমি নেক্সট ক্লাসে দেখাবো। ওখানে গিয়ে সিগনিফিকেন্ট লেভেলটা 10%, 5%, 1% করে দিতে পারেন। Is that clear to everyone?
Yes, sir.
Yes, sir.
So after that, let me call your attendance. আচ্ছা, অ্যাটেন্ডেন্সটা কল করার মতো আজকে আর আমার শরীরে শক্তি নেই। আপনারা একটা কাজ করেন, সবাই আপনাদের অ্যাটেন্ডেন্স আমাকে চ্যাট বক্সে মেইল করেন। আমি 5 মিনিট ওপেন রাখছি। 5 মিনিটের মধ্যে সবাই যার যার আইডি, শুধু আইডি জাস্ট টাইপ করে আমাকে সেন্ড করেন। ওকে, জাস্ট send me your ID in my chat box. Okay, everyone, I repeat, send me your ID in my chat box. বুঝতে পেরেছেন সবাই?
Yes, sir.
দিচ্ছেন সবাই?
Yes, sir.
Okay, so if you just put down your ID, just leave the meeting. Okay, I will remain open it for next 6 or 7 minutes, and after that I will automatically shut down the program, shut down the meeting for all of you. Clear?
Yes, sir.
Thank you.
Sir, next class কি next week
আচ্ছা, আমি আরেকটা আরেকটা
হবে?
এখানে অ্যানাউন্সমেন্ট আছে। নেক্সট ক্লাস হচ্ছে নেক্সট উইকের টুয়েসডেতে হবে at 3 p.m. এখন থেকে মানে ডিউরিং দ্য রমজান উই উইল জাস্ট কন্ডাক্ট অনলি 1 ক্লাস পার উইক, বাট ওটা 3 p.m. এ হবে না। টাইমটা একটু ঠিক করে নেন। টাইম উড বি 2 p.m. Your class would be started from next week Tuesday at 2 p.m.
Okay, sir.
Okay.
Okay, sir.
Okay, sir.
Okay, then thank you. I will remain this meeting open for next 5 or 6 minutes and then it will automatically shut down. Just put down your ID in my chat box. Thank you all. I'm taking your leave. Okay.
Thank you, sir. Assalamu alaikum.
Walaikum salam. দিয়েছেন সবাই? হ্যালো, হ্যাঁ বলেন।
স্যার আমি অ্যাটেন্ডেন্স দিতে পারিনি, আমার তখন নেট কানেকশন চলে গেছে।
আচ্ছা, না আমি বলেছি কি অ্যাটেন্ডেন্সটা সবাই আমাকে চ্যাট বক্সে ইনবক্স করতে।
ও আচ্ছা
যারা যারা এখনো লাইনে আছেন অ্যাটেন্ডেন্স দিতে পারেননি, আপনাদের আইডিটা শুধু আমাকে চ্যাট বক্সে ইনবক্স করেন, লিখে দেন। ওকে, আই গেস সবাই দিয়েছেন। Anyone left who did not send your ID in my chat box? ওকে দেন, তাহলে সবার সাথে দেখা হবে আগামী মঙ্গলবার, হ্যাঁ 2টার সময়। শুনতে পাচ্ছেন? ওকে।